Hello friends, in this video you will learn about how to find tension in a thread of a swinging pendulum. So this problem says a bob of mass m is attached to a string of length L and this is taken to the position as shown where the string is horizontal and released. We have to find the tension in the string where the vertical component of the bob's velocity is maximum during its motion. So here what we have, initially this is the position of the pendulum, and then what we have done is we have taken this pendulum to this position and from here it has been released. So initially it has been released with zero velocity and the mass of pendulum is given, that is m, and length of pendulum is also given, that is L. So m is given and L is given. Initial velocity u is equals to 0, this is also given, and we have to find tension in the string when the velocity, vertical velocity is maximum, where the vertical component of bob's velocity is maximum. This means this we have to find when Vy is maximum. So let us say after some time this bob has reached here and let's say this angle is given, this angle is theta. Now at this point of time velocity of this bob is v and this velocity will be tangential, something like this. So velocity is in this direction. So this is a tangential velocity and the magnitude of this velocity let's call v. So now this velocity will have two components, one component in this direction, another component is in this direction. Let's call this component as Vx and this component as Vy. Basically these are related, so if this is V and this angle will also be theta, so this Vy is nothing but V cos theta. So basically we have to maximize V cos theta. At this point of time tension in the string is T and another force that is acting, that is mg, so mg is also acting. So now how you will solve this problem? So two hints are here. You have to write energy conservation. One equation will come from energy conservation and another equation that will come from circular motion. Circular motion. So in circular motion what you will write? You will write force in the radial direction is equals to mass into acceleration in the radial direction. So let us take these hints and pause this video and solve this problem. Okay, so let us solve this problem. One correction here. In this case, this angle that I said this is theta, basically this is not theta. This part is theta. So this angle is theta. So this will be Vy will be V sin theta. So let us try to solve. So first we will write energy conservation equation. That is gain in kinetic energy is equals to loss in potential energy. So how much kinetic energy has been gained? Initially 0 velocity and finally v velocity. So gain in kinetic energy is half mv square. And loss in potential energy is how much? mgh. And where h is this distance. So h is this distance. So this value will be, let us say this is L, then this will be L cos theta. So mgh will be simply mgl cos theta. So from here I can write v square is equals to, this m gets cancelled out, So we will have 2ZL cos theta. So V is equals to under root 2ZL cos theta. So now once I know V, I can calculate V by. So what is V by? Which is equals to V sin theta, and V I know, that is under root 2ZL cos theta times sin theta. Now what is my target? We want to maximize this velocity. So we have to maximize. So either you maximize V by or you maximize V by S square. Both is the same thing, because I am maximizing V by S square just to eliminate this square root. So what I will do is dV by S square, and V by S square is a function of theta. So this will be, and this will be d by d theta, and Vs square will be 2ZL cos theta and then sin square theta. So if you differentiate this, dV square by d theta, so this will be 2ZL, and differentiation of cos theta is minus sin theta, and sin theta will remain as it is, plus cos theta, and differentiation of sin square theta is 2 sin theta, and sin theta differentiation is cos theta. So this is equals to 0. So from here you can say, if you take sin theta common, then you will have minus sin square theta plus 2 cos square theta is equals to 0. So there are two possibilities. Either you will have sin theta is equals to 0, or you can have, this is tan square theta is equals to 2. This means tan theta is equals to root 2. So this value, that is tan theta is equals to root 2, this will correspond to maximum. So this value is basically, this value will correspond to maximum. We will check both these values later. Basically when sin theta is 0, V by is 0. So this is not maximum, this is minimum. If you remember what was V by? V by was under root 2ZL cos theta times sin theta. So this corresponds to minimum. You can also check by second differentiation. So you can use d2V by or V by S square divided by d theta, whether it is greater than 0, less than 0, and based upon that you can decide whether this is a maximum or minimum. So now I know that is tan theta is equals to root 2, then I will have maximum tension. No, maximum velocity, and then correspondingly we have to find maximum, we have to find tension. So how will you find tension in the string? If you remember, we can write one equation along the radial direction. So this force is tension T, and then in this direction we have a component of mg. So this component in this direction will be mg cos theta, because this angle is theta. So this angle is theta, we have already said this angle is theta. So we can write T minus mg cos theta is equals to mv square by L. And we already calculated Vs square. So if you remember, we already calculated Vs square, that is 2ZL cos theta. So Vs square by L is basically 2G cos theta. So this means T is equals to 3mg cos theta. So this is my tension. What will the value? Tan theta is root 2. This means if this is the theta, then root 2, this means this is root 2, this is 1, and in this triangle this will be root 3. So cos theta will be simply 1 by root 3. So this is 1 by root 3. So the tension will be T is equals to mg by root 3. Now this problem you can also solve in rotating frame. So you can try in the rotating frame also. And let us do this differentiation on your own and prove that one corresponds to maximum and another corresponds to minimum. And let us discuss this in the comment box, whether you are getting this maximum or minimum or not. And if something is not coming, then please let me know in the comment section. So I hope you enjoyed this video. If you enjoy, please like, share and subscribe to my channel, and I will see you in the next video. Thank you.